Today we are going to see the fourth unit, that is memory and programmable logic. We are going to see the fourth unit, memory and programmable logic. Okay. Now, what is memory? Memory is a device to which information is transferred for storage or from which information is available for processing as needed. So it is a device to which binary information can be transferred for storage, or from that device the information can be retrieved for some processing. Now, what is memory unit? It is a collection of cells together with associated circuit capable of storing a large quantity of binary information. What is memory unit? Memory unit is nothing but a collection of cells together with associated circuit capable of storing large quantity of binary information. Now, block diagram of memory unit. So this is a block diagram of memory unit in which you're having k inputs. Input is nothing but the address, and it is having n outputs. And this is a block diagram. Usually you will representing the ROM as 2 to the power k into n. N represents outputs, and this k represents the number of inputs, that is the address lines. So the k address lines, they will select one particular word from this memory. So read and write are the two operations that we can perform in this memory. So writing is nothing but storing some information into the memory is called writing, and retrieving some information from the memory is called reading. So it will be having n data input line. So for writing we have to give data inputs that will be giving to the n data input line, and data we will be retrieving from the uh, memory. It will be coming from n data output line. Now, capacity of a memory. Usually the capacity of the memory range between 2 to the power 10 to 2 to the power 32 words. So you know that 1 kilo means 2 to the power 10, and mega means 2 to the power 20, and giga means 2 to the power 30. And usually we will be representing the memory like this. Memory, that is 1k into 16. The 1k means 2 to the power 10. So it will be having 10-bit address, and each word will be having 16 bits. Okay. So this 2 to the power k, you know that k represent determine the number of bits for address. So 2 to the power k should be greater than or equal to m. So k is nothing but the number of address bits, m is the total number of words. Now control inputs to the memory chip. So when the memory enable is 0, then no operation can be done. So when memory enable is 1, and when you are giving 0, then write operation can be, we can write some data into the memory. Similarly, the memory enable input is 1, and we are having 1, then we can read some information from the memory. Okay. So the next one is memory cycle timing waveforms. Waveforms for the read and write operations. There are first one, access time. Access time is nothing but the time required to select a word and read it. So what is access time? Access time is nothing but the time required to select a word from the memory and to read it. And cycle time is nothing but the time required to complete one cycle. Access time cycle is nothing but equal to fixed number of CPU clock. This is a memory cycle time waveform, and this is the clock. So we are considering three clocks, T1, T2 and T3. So we are having three square waveforms. Okay. So we are considering, and first this is nothing but the memory address. So memory address, next one is a memory enable, then next one is a, this is a read write, and this is a data input. So first one is we are writing some information into the memory. So first during the first positive edge of this clock pulse, you are making this address line. This is memory. top line is memory, the bottom line is address. You are making the address line high so that the information at the particular address can be retrieved. Okay. So first we are making the address line high. Then we are making the memory enable. That is, we are making the memory signal to the memory enable high. Okay. Then the type of operation what we are performing is write operation. So we are making it low, and we are making it low, and so this is nothing but write operation. So in this particular time, the data, this is data input. Huh? The data what you are giving, the input data, it is written in this particular T1 to T2 within T3. The data is written in the memory. So first, once again, I am telling. So during the start of T1, we are making the address line high. Then we are making memory enable high, and we are making a read write line low, and the data input line we are making high, and the data is written into the memory. Now we are coming to read operation. So the read operation also we are making address, we are making the address line high. So we have to read the information from the particular address, so we have to make that address line high. Then we are making the memory enable line high. Then we are making this read write line high. In the place in the right cycle we have made it low, but here you have to make it high. And at the end of this T3, the data input, this is data output, we are getting the valid data at the end of the T3. Okay, this is memory cycle timing waveforms for read and write and read cycles. Okay. Now next one is types of memory. So there are two types of memory, mainly RAM, and another one is ROM. RAM is volatile. Volatile means when power is off, the memory will not be stored there. So non-volatile means even in the if there is a power failure, the information stored in the memory will be present there. So in RAM, there are two types of RAM, that is static RAM, and another one is dynamic RAM. So in static RAM, the data is stored in the internal latch, and it is easier to use, and it is having shorter read and write time. But in the case of dynamic RAM, the data is stored as electric charge on capacitor. It consumes less power, and it is having large storage capacity. These are the main difference between static and dynamic RAM. In static RAM, the data is stored in internal latch. It is easier to use, and it is having shorter read and write time. In dynamic RAM, the data is stored in the as a charge on capacitor, less power consumption and larger storage capacity. Now we come to ROM. ROM is nothing but read-only memory, and this RAM is called random access memory. So ROM is a non-volatile ROM, non-volatile memory. So the meaning of non-volatile means even if the power failure occurs, the data will be stored in the ROM. So here the read write time depend on the distance between the magnetic reader writer and the data. So it only depends upon the distance between the magnetic reader writer and the data. That is ROM. Now main difference between RAM and ROM. RAM is volatile and ROM is non-volatile. Then RAM is random access memory, and the type of RAM is static RAM. In static RAM, there are two types: synchronous RAM and asynchronous RAM. In dynamic RAM, there are many types: FPM RAM, EDO RAM, SD RAM, DDR, SD RAM, DDR2, SD RAM, etc. These are the types of dynamic RAM. In the case of ROM, it is non-volatile. It is mainly used in system and video BIOS. The types is programmable read only memory. So here it is one time programmable. Next one is erasable programmable read only memory. Here using ultralight we can erase the ROM, and the last type is electrically erasable programmable ROM. So here by using some software you can reprogram. Now Next one is RAM. We are in detail, we are studying what is meant by RAM. RAM is nothing called random access memory, a type of computer memory that can be accessed randomly. The main thing is we can access this memory randomly. That is, any byte of memory can be accessed without touching the preceding bits. So if you want to access a particular bytes without touching its preceding bits, you can access the memory. This is nothing but random access memory. So this random access memory is a common type of memory found in computers and other smartphones, etc., other devices. Now, the main feature of this RAM is nothing but it is volatile. Volatile means when power failure is occurring, data will not be stored in this RAM. So a RAM must be provided with a constant power supply. So without power failure, we have to maintain if you are using RAM. If power is interrupted, the data gets lost. So thus RAM can be used only as a temporary storage. The two traditional forms of RAM are used in computers are DRAM and SRAM. DRAM is nothing but dynamic RAM and SRAM is nothing but static RAM. Again, RAM is a volatile chip memory in which we can perform both read and write operation. So it is also called as read-write memory. So in RAM you can perform both read and write operation, but in the ROM you can perform only read operation. So the time it take to transfer information to and from any desired random location is always same. So in RAM, the time taken to transfer the information to the RAM as well as from the RAM, the time is same. So we are storing in terms of bytes. We know that 8 bytes is nothing but 8 bits is nothing but a byte. Length of the word will be in terms of multiples of 8 bits. Either it is 16 or 32 or 8. So word is nothing but a represent a number, an instruction or alphanumeric character. So the capacity of a memory is nothing but the total number of bytes of data it can store. So the RAM it can be divided into two types. That is, it can be made by either bipolar or MOS. So this RAM can be made by two things. One is bipolar. By BJT you can make this RAM, and second one by MOS you can do this ROM. In bipolar there is only one type, static, and in MOS there are two types, that is static and dynamic. So in bipolar there is only static RAM, but in MOS it's having both static and dynamic. Once again, RAM it can be done by two things, one is BJT and another one is MOSFET, and in bipolar you are having only static RAM, in MOSFET you are having both static and dynamic RAM. First we are going for static RAM. So static RAM is a digital device, but dynamic RAM is an analog device. Static RAM is a digital device that uses the same logic elements used in processor. So it is using the same logic elements used in the processor. In SRAM, binary values are stored using traditional flip-flop logic gate configuration. Initially, I have told that in static RAM, the binary values are stored in flip-flop. A static RAM will hold data as long as power is supplied. Since it is volatile, it will be storing data as long as only power is given to it. So unlike DRAM, no refresh is needed to retain the data. So in dynamic RAM, we have to refresh every time, but here there is no need of refreshing. So as in the DRAM, yes, SRAM address line is used to open and close a switch. So in order to open or close a switch, we need the address. Next, the address line controls two transistors. When a signal is applied to this line, the two transistors are switched on, allowing a read or write operation. Next, static RAM. A static RAM contains an array of flip-flop, one for each stored bit. So it will be having an array of flip-flops, one for each bit. Data written in the flip-flop remain as long as the DC power is maintained. So since it is volatile, so data will be remain in the flip-flop as long as the DC power is maintaining. The capacity of a RAM varies from 64 bits to 1 megabit. To select the cell, both the row and column must be held high. So in order to select one particular cell, both row and column must be held high. So memory will be having many cells. So group of cells form the memory, and to select an individual cell, we have to both the row and column must be high. When selected, data bit can be stored in the cell or content from the cell can be read. So after selecting, the data bit can be stored in the cell or the content from the cell can be read. So if either row or column select line is low, then the memory is disabled. So if you are making the row and column select lines low, then the memory cell is disabled. The input bit, that is 1 or 0, is written into the cell by setting the flip-flop for a 1 and resetting the flip-flop for 0 when read-write line is low. So the input data bit, either it may be 0 or 1, is written into the cell by setting the flip-flop for a 1 and resetting for a 0. So if you want to 1, we have to set the flip-flop to 1, and if you have to give 0, we have to reset the flip-flop when a read-write line is low. So the meaning of read slash write bar means when you are giving 0, then the write operation has to be done. When you are giving the control signal 1, then read operation has to be done. So when you are giving 0, write operation has to be done, and when you are giving 1, then read operation has to be done. When the read and write line is high, the flip-flop is unaffected. So when you are giving read write line high, the meaning is we are reading the operation. So no, and the flip-flop is unaffected, and what the thing available in the flip-flop, it is retrieved. Then the stored data is gated to the data outline. That is nothing but reading. So the flip-flop in the static memory can be constructed by using bipolar junction transistor or MOSFET. So already we seen that data is stored in the static RAM in flip-flops. So the flip-flops can be done by either BJT or MOS, bipolar junction transistor or MOSFETs. So bipolar junction is nothing but a bipolar device, and MOSFET is nothing but a unipolar device. Now this is nothing but the diagram of bipolar static RAM. So here it is having two transistors Q1 and Q2. How many transistors it is having? It is having two transistors Q1 and Q2. And this Q1 and Q2 are multi-emitter transistors. It is having three emitters. So it is a multi-emitters transistors. Another important feature is nothing but it is a cross-coupled. These two are cross-coupled transistors. The advantage of cross coupling is if one transistor is on, then another one will be off. If Q1 is on, then Q2 will be off. If Q2 is on, then Q1 is off. So this is nothing but cross coupling operation. Okay. So to one of the emitters, it is connected to X select, and another emitter it is connected to Y select. Similarly, one emitter is connected to data line and another one is connected to data line 2. One is data line 1 and another one is data line 2. So this is a circuit diagram of bipolar static RAM. It is having two transistors, and the two transistors are multi-emitter transistors connected in cross coupled mode, and it is having three emitters. Okay. It is having three emitters to the one of the emitters, the X select line is connected to another emitter is connected to the Y select line. Another one is in data line and another one is data line 2. Now we will see the working of this. It consists of two transistors Q1 and Q2 and that are cross coupled to form a flip flop. So these it cross coupled and we are forming a flip flop. When Q1 is on, Q2 is off due to this cross coupling connection. The Q1 is when Q1 is on, Q2 will be off. Here each transistor is having three emitters, a row select, a column select and a right input. So it is having three emitters, that is row select, column select and right input. Now a 1 is stored in the cell if Q1 is conducting and Q2 is off. A 1 is stored in the cell if Q1 is conducting and Q2 is off. We know that there are two transistors. If the transistor 1 is conducting, then the 1 is stored in the flip flop. A 0 is stored in the cell if Q1 is off and Q2 is conducting. If Q2 is conducting, a 0 will be stored in the cell. The state of cell is changed to 0 by pushing high to to on the Q1. So actually we can change the state of the circuit. How means we can, if you're giving a high voltage to the emitter, then Q1 will automatically turns if you give a 1 to an emitter of Q1, then the state of the cell will be changed to 0. So if you are giving 1 to the emitter of Q1, then it will Q1 will turn off. When Q1 is turned off, Q2 will turn on. This is a speciality of cross coupling. As long as Q2 is turned on, its collector is low and Q1 is held off. A 1 can be rewritten by pushing Q2 emitter high. So if you give 1 to the emitter of Q2, then Q2 will become on and 1 can be rewritten. So when you give 1 to the emitter of Q2, if you give 1 to the emitter of Q2, then it will become Q2 will become off. Whenever we are giving a high to a particular transistor, then it will become off. If you are giving a high to Q1, Q1 will off. If you give 1 to and Q2, Q2 will become off. So if Q2 will become off, Q1 will become on. So if Q1 is on, then automatically 1 will be there. Okay. So that's the so we are yeah, 1 can be rewritten by pushing Q2 emitter high. So next one is MOS static RAM. So we have seen the RAM using bipolar transistor. So now we are going for MOS, metal oxide semiconductor static RAM. So here you are having totally 8, 9, 10, 10 MOSFETs. Okay. So here T1 and T2 are cross coupled MOSFETs and this T3 and T4 it acts as the resistance. Okay, it acts as resistors, these transistors. So this T5 is connected to row, the T5 and T6 is connected to row select. Okay, then T5 and T3 is also connected to data line and data bar line. Okay, now we are going for the working. So this T7 and T8 is connected to Y column select. This T3 and T4 is connected to X row select and T7 and T8 is connected to Y column select. So in T9, if you get if you give supply to the gate of T9, then write operation can be done. So if you give signal to the gate of T10, then read operation can be done. So in through by giving signal to the gate of T10, read operation can be done, and by giving signal to the T9, gate of T9, write operation can be done. Now we are going for the explanation. Here the MOSFETs what you are using is nothing but enhancement type MOSFET. Here transistors T1, T2 form the basic cross-coupled inverters, and T3 and T4 form the load resistors. In that circuit, T1, T2 are the cross-coupled inverters, and T3 and T4 form the load resistance. Then X and Y are used for addressing the cells. This X and Y lines are used for addressing the cells. When both X and Y lines are high, particular cell is selected. So when we are having X lines and Y lines, and when both this X and Y lines are high, particular cell is selected. When X is 1, T5 and T6 get on, and the cell is connected to the data and data bar line. Okay. When X is 1, you see this figure when X is high, this T3 and T4. So sorry, this T5 and T6. Check clearly when you are when you are making rho equal to 1, this T5 and T6 they they are on and they are connected to data line and data bar line. So what is happening when row select is equal to 1, this T5 and T6 are high, and they are this data and data line are connected to these two transistors. So due to this, either write or read operation is possible. So if you are giving X and Y lines, when X is 1, T5 and T gets on, and the cell is connected to the data and data bar line. Due to this, either we can make the read and write operation possible. Now how we are performing write operation. So in order to make write operation, we are making this W signal high. Then with write operation enabled, if data in signal is logic 1, the node D is also logic 1. This turn on T2 and T1 is cut off. If a new data on data, if new data on the data in pin is logic 0, T2 will be cut off and T1 will be turned on. So I will clearly explain with the figure how this write operation is. We are going to see the write operation. So please listen. Initially, we are making row line as high. So when you are making row line high, T5 and T6 are on. Similarly, when you are making Y line high, T7 and T8 are on. Okay. Now you are making this write as 1. The meaning is you are making this transistor T9 on. So and you are giving data here. So already T7 is conducting. So now since you are giving 1 to the gate of this transistor T9, it is also conducting. And the input what you are giving, assume that it is 1. It is coming to here. Then already this transistor T7 is conducting. So this 1 will be coming to here. Then since row line is high, this T5 is already conducting. So you are having 1 in the data line 1. So this 1 will be stored here, that is in the place of D. Now the value of D is 1. So a 1 is written in this transistor. Now this is how the write operation is performed. So we have performed the write operation. So once again I am explaining the write operation. So if you are making X row select line 1, T5 and T6 is on, T5 and T5 and T6 is on. And when you are making this Y column select high, T7 and T8 is on. Now I am going to write a logical one first. I am going to write logical one first. So I am making this right line 1. So what I am making? I am making this right line 1. So this right line 1 means you are giving signal to the gate of this MOSFET. So and you are giving a logic 1 in the place of data in. So this transistor, this MOSFET will conduct. It will be getting the output here. Already since you make this column select line high, T7 is conducting and you'll be getting a 1 here at the data line. So Q, this T5 is already conducting due to this X row select is high. So we'll be getting 1 here. That is at D we will be getting 1. So at that time T2 will be on, get on, and T1 will be off. What happens when you are writing a 1 here? This you will be getting a 1 at T, and T2 will be on, and sorry, T2 will be on and T1 will be getting off. So this is writing 1. So then I will explain writing 0. So for writing 0 also, already this T5, T6, T T7 and T8 are on. Now I am giving a signal 1 to this right line. So and I am giving a logic 0 to data n. Since T9 is conducting, I will be getting 0 here, and since T7 is conducting, I will getting the 0 at this point, and at data line I will be getting 0 since T5 is conducting due to this X row select line is 1. I will be getting a 0 at this point. So since I am getting 0 at this point, T2 is becoming off and T1 is on. So what happens when you are writing a logic 0, T1 is on and T2 is off. When you are writing logic 1, T2 is on and T1 is off. Okay, this is a condition for data writing, write operation. Next, I will explain what happens for read operation. Already when you are making X row select and Y column select, this T5, T6, T7 and T8, this gets on. What are the things? T5, T6, T7 and T8. Now we are going to read data. What we are going to read? We are going to read data. Now we are making a read signal high. What we are making? We are making read signal high. And now the data bar line, when you are when this when you are making this read line as 1, this data bar line will be connected to the data out. This is nothing but here will be getting data out. Since T8 is conducting, the data what you are having here you will be getting at this point. So what, whether it is 0 or 1, but due to the this transistor T10 is conducting, whatever thing it is having in the input, here it will be getting as output. But the data out what you are getting is nothing but it is the complement of the actual output. Okay, so since the data bar line is connected to the output what you are getting is nothing but the complement of what you have to get. Okay, this is nothing but data read operation. So in data read operation, what you are doing is you are making X row select line high and X column select line high, and it is making this T5, T6 and T7, T8 on. Then you are giving a signal one. You are giving a high signal to this transistor T10, and this due to that this transistor gets on, and that line will be connected to this data bar line, and this output that is present in the data bar line will be got at the output, since it is the complement of the data. So the output what you are getting is nothing but the complement of actual data. So this is nothing but the, so once again I am explaining the write operation. Write operation can be enabled by making the W signal high. So how we are making? You are making the W signal high. When you are making this W signal high, write operation is enabled. With write operation enabled, if the data is what you're writing is logic 1, the node D is also at logic 1, and it makes T2 on and T1 off. Then the new data what you're writing is logic 0, then T2 will become off and T1 become on. Okay, T1 become on and T2 become off. So now we are going for read operation. Read operation can be enabled by making R signal high, read signal high. Okay, then write operation enables enable the transistor T10 becomes on. So once that read operation is enabled, what happens? The transistor T10 becomes on. Disconnect data output data bar line to the data out. Okay, this connects the data output data bar line to the data output, and the complement of the bit stored in the cell is available at the output. The output what you are getting is nothing but the complement of the bit stored in the cell. Next one is dynamic RAM. So we are going for dynamic RAM. This is a symbol diagram of dynamic RAM. Okay, so here you are having a capacitor. This is a row line and column line. This is a row line and this is column line, and you have connected one MOSFET to this row line and column line. When you are making row line and column line, in other words, it is control line and sense line. When you are making these two high, then the transistor will get conduct and it will charge the capacitor. So what happens? It will charge the capacitors, and the information is stored in the capacitor as charge. So this is a simple cell of a dynamic RAM. Dynamic RAM is made with cells that stores data as charge on capacitors. So in dynamic RAM, the data is stored as charge on capacitors. The presence or absence of the charge in a capacitor is interpreted as binary 1 and binary 0. If there is charge, then it is 1. If there is no charge, it is 0. Then, because capacitors have natural tendency to discharge, dynamic RAMs require periodic charge refreshing to maintain the data storage. So, you know that the capacitor, after charging, it will discharge. So, this dynamic RAM must have the refreshing facility to maintain the data storage. In order to maintain the data storage, we need some refreshing. We have to refresh the RAM periodically. So in order to maintain that data, okay. So we need DRAM cell has cells. The individual cell stores 1 bit. The DRAM will be having cell, and it will stores 1 bit. What does mean by bit? Bit means binary digit. The address line is activated when the bit value from the cell is to be read or written. Some, if you want to write some bit value, or some, if you want to read some bit value, then the address line has to be activated. So by knowing the address only, we can retrieve the data, and by knowing the address only, we can write where to write. Okay, so we need address. So transistor acts as a switch that is closed, allowing the flow of current, since it is charging the capacitor. So it will, once the capacitor when the transistor which acts as a switch, when it is closed, it will allow the flowing of current. Okay, if a voltage is applied to the address line and open if no voltage is present in the address line. So if some voltage is present in the address line, then the current will flow and it will charge the capacitor. If there is no voltage present in the address line, no current will flow. For write operation, a voltage signal is applied to the bit line. A high voltage represent 1 and a low voltage represent 0. So a high voltage it will represent a 1 and a low voltage will represent 0. For a write operation, a voltage signal is applied to a bit line. What you're giving a voltage signal to the line, particular line. If a high voltage is given, it is meaning that we have one has to be written. A zero, if you're giving a low voltage, then it represents 0. Although DRAM cell is used to show single bit, it is essentially an analog device. But the static RAM is a digital device and this dynamic RAM is an analog device. So how to write a one in the memory cell? Now we are going to study how to write a 0 into the memory cell. So this is nothing but the dynamic RAM cell. So it is having a MOSFET and a capacitor. So to this, we are having three buffers. One is refresh buffer, another one is output buffer, and another one is input buffer. Here you are having three buffers. So one is input buffer, another one is output buffer, and another one is refresh buffer. Of these three buffers, this input buffer is a inverter buffer, and this refresh buffer and the output buffer are normal buffers. So this here how many buffers you are having? Three buffers you are having. One is refresh buffer, one is input buffer and the output buffer. The input buffer is a inverter buffer. So all the refresh buffer and output buffer are normal buffers. So for write operation, here the row line is first we are making the row line high. Okay, what you are making? We are making row line high. Then so for writing operation, we are making read write line low. So when you are making this read write line low, it enables the input buffer and it disables the output buffer. Why? Because this is a normal buffer. When you are giving low, it gets disabled. But the input buffer is an inverter buffer. So if you are giving a low signal, then it gets enabled. Now here we have made this row line high. So due to this since the row line is high, this transistor is on. Now we are giving input low. We are writing a 0. So we are giving an input low to the input buffer. So this out this since this input buffer is enabled, you will be getting a low at the output. So this column line will become low. So this capacitor will not charge. So it will not charge. If it is having charge, then it will start discharging. So what happens? It will start discharging. So this is nothing but writing a 0 in the memory cell. So I will explain once more. For writing, what you have to do means first we have to make the refresh input to the refresh buffer low. Then you have to make this row column high. This is a row column that you have to make it as high. Then you have to make the read write line low. This disables the output buffer, it enables the input buffer, and you are giving the input D in as low. So due to that you will be getting the output D at this point and the column line become low. Due to that the capacitor will not charge. It will discharge if it is charged in the previous cycle. So this is nothing but writing a 0. Okay, if you are making this row line low, then this capacitor will be disconnected from this line, and the 0 will be stored in the capacitor. Okay, this is nothing but the writing a 0 in the memory. Now we are going to see writing a 1 into the memory cell. So this is a dynamic memory. So here we are having here the data is stored as charge in the capacitor. Okay, here you are having three buffer, one refresh buffer, one input buffer, and one output buffer. The input buffer is the inverter buffer, and the refresh buffer and output buffer are normal buffers. Okay, so here for writing one into a memory cell, first what you are doing is first we are making row line high. First what you are doing, first we are making row line high. So we are making row line high. So making this row line high will turn on the transistor. So what it will make, it will turn on the transistor, MOS transistor. Then what you are doing is we are making the input to the refresh buffer low. So what you are doing, we are making the input to the refresh buffer low. So it will disable the refresh buffer. Similarly, we are making the read write line low. So what you are doing, we are making the read write line low. So making the read write line low will disables the output buffer and it will enables the input buffer. So what happens when you're giving low to the read write line, it will disables the output buffer and it will enables the input buffer. So here what we are doing, we are going to write a 1 into the memory cells. So we are giving data in as high. What you are doing, we are giving data in as high. So the output of your data input buffer will be 1 or high. So you're giving D in as 1 or high and the output of your input buffer is 1 and this 1 is connected to the column. So this line is 1. So already the transistor is on. Now this column line is 1. So this capacitor gets charged. So this capacitor gets charged and 1 is written into the capacitor and here the data is stored as charge in the capacitor. So here how we are storing this data? Data is stored as a charge in the capacitor. So if we are making that row line low, then this capacitor will be disconnected from this transistor, and that one will be stored in the capacitor. Okay, this is nothing but writing one into the memory cell. Once again, I will tell how to write a 0 into the memory cell. So, writing a 0 already I have explained. Once again, I explain. First, what you are doing is you have to make the row high. It will make transistor on, MOS transistor on. Then you have to make this refresh buffer input to the refresh buffer low. Here you are having three buffer, refresh buffer, input buffer, and output buffer, and we are making the refresh buffer low. So it will disable the refresh buffer. Then we are giving low to the read write line. So it will disables the output buffer and it enables the input buffer. Since we are writing a 0, we are giving D in as 0. So the output of your input buffer is 0. What output you are getting at the output of input buffer? 0. This 0 is connected to the column line. So this capacitor is not charging. So it will not charge. So since you are having 0, the capacitor it is on, but it will not charge. So if it is charged in the previous cycle, it starts discharging. What happens if it is charged in the previous cycle? It starts discharging. So we have written a 0. So if this row line is made low, then this capacitor will be disconnected from this transistor and a 0 will be stored in the capacitor. So we have studied how to write 1 into the memory cell and how to write 0 in the memory cell. That is nothing but dynamic memory cell. How to write a 0 and how to write a 1. Here you are having three buffers: input buffer, output buffer, and refresh buffer. For write operation, the thing what you're doing do is first you have to make the refresh buffer input to the refresh buffer 0, then you have to make the row line high and it makes the transistor on, then you have to give a low input to the um, read write input low, and when you are giving the low to the read write input, it will enables the input buffer and it will disables the output buffer. And if you want to write 0, then you give input as 0, and and this input 0 will not charge the capacitor, and a 0 will be returned. If you give an input of 1, then the column line will become 1 and the capacitor starts charging, and it will start, and 1 is stored in the memory cell. So we have studied how to write a 1 and 0 in the memory cell. Now we are going to study how to read from the memory cell. So first, what you have to do means you have to make the refresh buffer low. First, what you have to do, you have to make the refresh buffer low. Then you have to make the row line high. Then you have to give this read write line high. So by writing operation, we have given read write line low, but here in reading operation, we have to make this read write line high. So by making this read write line high, this output buffer is enabled and this input buffer is disabled. What happens? The output buffer is enabled and the input buffer is disabled. So this the input of the output buffer is connected to the MOSFET, and since the MOSFET is on, that data present in the capacitor, it will be coming out as a in the output buffer. So since the input buffer is enabled, the capacitor is connected to the input buffer, and and that input will be coming as the output in the D out line. Once again, I am telling how to perform the read operation. In order to perform the read operation, first we have to make the refresh input to the refresh buffer low. So making the input to the refresh buffer low will make the refresh buffer disabled, and then we have to give high to the column line. So giving the high input to the column line will make the MOS transistor on. Then what you are doing is we are giving a high or 1 to the read write line. So giving a 1 to the read write line will make the output buffer enabled and the input buffer disabled. Why? Because the input buffer will be only enabled if you are giving 0, and the output buffer will be enabled when you are giving 1, because input buffer is a inverter buffer, so it is disabled. Now the capacitor is connected to the column line. That column line is connected to the output of output of the output buffer through the input buffer. So we are getting the data out of that uh, memory cell. This is nothing but reading operation. Getting a data out of that memory cell is called nothing called reading operation. So next we are going to see refresh operation. Now we are going to see the refresh operation. So the main thing what you have to remember is, now you have to make this refresh input to the refresh buffer high, and we have to make the row column high, and we have to make this read write line high. So in the write and read operation, we have made this refresh input to the refresh low. Now in the refreshing operation, we have to make this refresh input to the refresh line high. Then we have to make the row line high, and we have to make the read write line also high. So giving a high input to the row line will make the transistor on, and giving a high input to the read write line will make the input buffer disabled and the output buffer enabled, and giving a 1 to the refresh buffer or high to the refresh buffer will make the refresh buffer enabled. Now now when you're giving, yeah, uh, since the read write line is high, output buffer is enabled, and the the value stored in the capacitor is connected to the output, is connected to the output, and this output, it is connected as the input to the refresh buffer, and since the refresh buffer is enabled, it gives the output nothing but the values stored in the capacitor, and this capacitor is replenished once again. So refreshing operation is performed. Okay, it is replenished once again, and the reading operation, the refreshing operation is performed once again. I will explain. In refreshing operation, we are making that refresh buffer high, then we input the refresh buffer high, then we are making the row line high, then we are making the mm, read write input high, and making the read write input buffer will make the input buffer disabled and the output buffer enabled. So the capacitor, the value which is stored in the capacitor, it is coming as the output. Now we are assuming that we are stored a 1, so we are getting a 1 here, and that one, it is connected to the input of refresh buffer. Since we are giving a high input to the refresh buffer, it gives a 1 here, and this column line will be high, and once again the current will be flowing here, and this capacitor is replenished once more. Okay, it will replenish the capacitor, or it is, we are refreshing the capacitor, the value is refreshed. Okay, so it prevents the capacitor from discharging. Okay, if the capacitor is discharging, the value will be lost. So by using this refreshing operation, we are maintaining the value which is stored in the dynamic memory cell. Okay, so we have studied the write operation, read operation, and refreshing operation. Now we are going for the advantages of the dynamic RAM. Very large memory array can be constructed at lower cost. By using this dynamic RAM, very large memory array can be constructed. Then it offers reduced power consumption. So this dynamic memory offers reduced power consumption, and large storage capacity can be possible. Then disadvantages: mass capacitor cannot hold the stored charge over extended period of time. So it can't uh, store the charge for a long time. So it has to be refreshed every few seconds. So this is the disadvantage. We have to refresh the capacitor, so only we can maintain the charge. The circuit becomes complex. So the circuit is complex. So we need three buffers and all. So the circuit is somewhat complex. So we are checking what is the similarities and difference from between SRAM and DRAM. Both SRAM and DRAM are volatile. Both static and dynamic RAM are volatile. Dynamic memory is simpler and smaller than static. It is smaller and simpler. Then DRAM is more dense and less expensive. It is less expensive. Dynamic RAM is less expensive. Then DRAM requires supporting circuitry for refreshing. Then for large memory, fixed cost of refreshing circuit is more. So for large memories, the cost of the refreshing circuit is very more. So thus DRAM tend to be favored for large memory requirements. So these SRAMs are generally faster than DRAMs. What is SRAM? SRAMs are faster than DRAMs. So this static RAM is used for cache memory, and this is main point. Static RAM is used for cache memory, and DRAM is used for main memory. Then so SRAM, it is extremely fast, no refresh cycle, and here, so these are the difference between SRAM and DRAM. So DRAM is cheaper, high density, so but it is slower in speed, refresh cycle, application, computer memory. This is in latches, application in latches. So this SRAM, it is used, it need a large area, it is expensive. Okay, these are difference between SRAM and DRAM. Okay, these are the difference between this SRAM and DRAM. Speed is slow in DRAM, but it is more fast in SRAM.